Greetings and welcome. Today we're taking on a new subject, a very important subject, and that's the topic of Galileo, his science, his trial by the Vatican authorities, and more generally, his relationship to the history of science and to the history of knowledge and the formation of new ideas about how to understand the world and how to think about the world. I want to argue to you, I want to propose to you, that the most important part of this story is not the conflict between Galileo and the Catholic Church. Rather, the most important part of the story is the history of science, which we can learn from this story. Because Galileo was one of the most important innovators in the 17th century in creating a new science of the world. His science was mechanistic. He wanted to be able to understand all natural phenomena on the basis of the same fundamental principles of motion and physical interaction, which could be discovered through observation and hypothesis formation. And it is very significant that in the early modern period, the instrument of the clock was also being developed. And the idea of a clockwork mechanism, where the various mechanisms lead to the behavior of the clock. By understanding the mechanisms, we can understand the movement of the hands. Galileo challenged the Aristotelian conception of the universe, which had been in place really since only, 50 years after the death of Socrates. And the Aristotelian conception of the universe was dramatically different. It was based to some extent on observation, but more importantly, it was based on an effort to have a philosophically satisfactory understanding of the nature of reality. Galileo wanted to have a unified theory of matter and motion, but he also invented and used the first real scientific instrument, the telescope, and he made important astronomical discoveries. And then the discovery, the view, the scientific achievement, which brought him into conflict with the Catholic Church, he provided important intellectual and scientific support for the Copernican theory of the solar system, or as it might have been put at the time, the Copernican theory of the universe. So one of the topics which we're sort of forced to consider is what is the relationship between natural philosophy, which Aristotle provided, and natural science, which Galileo and a host of other thinkers in the late 16th century, early 17th century began to develop. Aristotle's theory of the world had specific theories of causes, objects, motion, and physics. He argued that all of the universe consisted of four substances: earth, water, air, and fire. But he also had a method for gaining knowledge. He recommended, and in this I think we still have an admiration for Aristotle, he recommended that we should observe, reason, draw inferences, and we should perfect our knowledge of a particular domain of the natural world. We, in other words, should not imagine that knowledge of the world can ever be complete and finished, but rather we need to continue to observe and reason and explore. And so Aristotle's theory of knowledge encouraged discovery and observation. And his own theories of nature discouraged the idea of closure, the idea of stopping investigation. And yet his theories also were taken to encourage dogmatism and conformity, and his metaphysical ideas became embedded in Christian theology through people like Anselm, which in turn led to a dogmatism which stood in the way of the progress of science in later centuries. Ptolemy was an ancient astronomer, and Ptolemy was empirically minded. He did very careful observations, and his generation of astronomy did very careful observations of both the stars, the moon, and the planets. And the most glaring observation of the planets is the fact that they do not have regular movements. Unlike the stars, which move apparently in perfect circles quote, around the Earth, the planets move in very irregular motion. They appear to wander. A quote from the Stanford Encyclopedia article on Copernicus: astronomers had developed the concept that the orbit moves in epicycles around a deferent. That is, the planets move like a flat heliacal coil around a circle around the Earth. The Earth was also off-center on an eccentric as the heavenly bodies moved around a central point. This is a very complicated description of the motions of the planets around the Earth. But I would emphasize that Ptolemy's system was descriptive rather than philosophical, and it was instrumental. It was designed to predict the positions of the planets in the future. And it's also worth emphasizing that Islamic astronomers in the 10th and 11th century were also careful observers of the heavens, carefully criticized and corrected Ptolemy's calculations in the 10th and 11th centuries, in other words, long before Copernicus. So what was Copernicus's theory? Copernicus was a Polish intellectual. He wrote one book, which was called On the Revolutions of the Celestial Spheres, On the Revolutions of the Celestial Spheres. He did his university studies. I say that as if it was common, but it wasn't common. And so I should say with celebration. He did university studies at the University of Krakow in mathematics and astronomy. He then studied in Bologna, and Italy was, if not the intellectual center of Europe, it was one of the intellectual centers of Europe, where perhaps surprisingly he studied humanities, not mathematics, not astronomy. But Copernicus came to reject Aristotle's theory of the universe, the theory of concentric spheres, but also of Ptolemy's theory with the eccentrics and the epicycles of the motions of the Earth, the planets, and the sun. And in Copernicus's time, it was possible to do planetary observations which were increasingly precise. And Copernicus appears to have concluded on mathematical considerations that the complexity and irrationality of the epicycles and eccentrics begs for a simpler physical theory of planetary motion. But, ironically, his system also required epicycles in order to remain descriptively accurate, observationally accurate. I should mention a free spirit, Giordano Bruno, whose example had a very searing effect on other intellectuals of the 17th century, 1600s and later. Here's a short description of Bruno from the Stanford Encyclopedia. Not by chance does Bruno have the distinction of being the only known 16th century philosopher to have been excommunicated from all three major confessions: the Roman Catholic Church, the Calvinist Church, and the Lutheran Church. Now that is quite an achievement, and clearly the author of the article is basically saying he was a particularly provocative philosopher. But here's the description of the end of Giordano Bruno. Events took a decided turn for the worse when on 12 September 1592, the papal nuncio in Venice, on behalf of the Holy Office in Rome, requested Bruno's extradition. The Venetian authorities dilly-dallied before eventually acceding to the request January 1593. At Rome, the trial proceeded slowly. Eventually, on 14 January 1599, the Congregation of the Holy Office approved a list of 8 heretical propositions assembled by Robert Bellarmine and Alberto Tragaglioli from the trial records and copies of Bruno's works. It's very interesting that the charges against Bruno are no longer known, but he was convicted and was burned at the stake. This is the point that Bruno's conflict with the church, the kind of point of exclamation which his conflict with the church had for other thinkers like Galileo, like Copernicus, like other intellectuals, scientists, and philosophers. But one thing we should understand is that the 17th century, the late 16th century, the 1500s or 1600s, this is what's referred to as the Renaissance or the early modern period, and it was an amazingly rich period of scientific knowledge and philosophical change. Copernicus lived 1473 to 1543, Galileo 1564 to 1642, and I've listed the books which he wrote. Descartes, the greatest French philosopher, lived in the same general time period, 1596 to 1650, and Descartes wrote a book called Le Monde, or The World, which, very interestingly, he withdrew from publication because of Galileo's conflict with the Catholic authorities. He also wrote a book which was widely published, The Meditations on First Philosophy, and if you've studied philosophy at all, I'm sure you've read some of Descartes' meditations. There are only 6 of them, I seem to recall. But Thomas Hobbes, the great English philosopher, lived at the same time, wrote the great book Leviathan. And then finally, finally in my listing, Baruch Spinoza, the greatest Jewish philosopher from the Netherlands, also lived at roughly the same time period, wrote a book called Theological Political Treatise. Each of these philosophers had some kind of interaction with Galileo. And in fact, I want to emphasize that Europe was a reasonably well-integrated intellectual world at the time of the late Renaissance, the early modern period. But let's zoom in on Galileo a little bit. We think of Italy as a country, but actually in 1500, 1600, Italy was not a country. Instead, it was a loose agglomeration of city-states. There was no central state authority, but rather there were various states: the Kingdom of Naples, the Republic of Florence, the Republic of Siena, the Republic of Venice, the Savoy, the Kingdom of Sicily. There were different political entities in Italy which were Italian, but they were not a part of an Italian state. At the time also, Catholicism was the dominant religion of most of Europe, and Catholicism and the Catholic hierarchy had great political power in Italy and in other parts of Europe, and the Pope had political power in a limited sphere. In particular, in matters of religious faith, doctrine, and heresy, the Church had jurisdiction. And now when we think about Galileo, the city-state of Florence was the home of the Italian Renaissance. So this is just to give you a little bit of a geographical understanding of the world at the time of the Renaissance. But the point I want to emphasize is we think of Galileo as an isolated thinker, but that was far from the truth. Galileo was immersed in a dense world of academic communication, of excitement from one side of Europe to the other limit of Europe, excited about scientific innovation, philosophical innovation, mathematical innovation, and there was extensive communication across academic communities across the face of Europe in the early 17th century. Galileo, in particular, corresponded with natural philosophers and scientists in many countries, and Galileo's work was well known in many countries across Europe. Philosophers like Thomas Hobbes were influenced by the theories and writings of Galileo. And in fact, this may surprise you, Hobbes visited Galileo and learned from him directly in short visits. He didn't go and study with Galileo, but he did meet him. Hobbes's knowledge of Galileo's work dates from the 1630s, in other words, about the time that Galileo's conflict with the Church came to a head. And his travels in 1630 as private secretary to Sir Gervase Clifton allowed him to be a very sophisticated traveler and intellectual across the face of Europe. What kind of communication existed during the Renaissance? Again, we think of Europe kind of coming out of the Middle Ages as being a kind of remote and isolated place, but that impression also is really not true. There was a great deal of intellectual communication taking place during the Renaissance, but also taking place during the medieval world. Scholars traveled from one European capital to another. Travel was not easy. One didn't hop on a plane. Travel was laborious. but it occurred, and intellectual stimulation happened between the capitals of France and Sweden and England, France, and Italy. There was a common language, the language of the church, the language of Latin, which provided a kind of lingua franca for scholars all over Europe. And intellectuals in each of these countries was also interested in communicating their ideas in the vernacular languages of their countries. And so Descartes was interested in writing not just in Latin, but also in French. But Hobbes in particular provided detailed criticisms of Descartes, and Hobbes was in turn influenced by Galileo. Communication across Europe occurred in a variety of mechanisms. Academic societies were beginning to be developed, and academic societies, for example, the Academy in London, which drew on regional experts, philosophers, mathematicians, scientists, within riding distance of London, and there were a great many of them. But there was also extensive correspondence by letter among leading scientists and philosophers. And the letters, it has been pointed out by many scholars, the letters were detailed letters. They were extensive letters. They were more equivalent to archival journal articles than simply to a postcard saying, hello, how are you? Major university centers hosted visitors from other countries, and the dissemination of books and pamphlets allowed the ideas of innovations in England to be relatively quickly known in Italy, innovations in Italy to be known quickly in Sweden, and so forth. And then finally, the church itself was a medium of communication throughout Europe and also throughout other parts of the world, the Americas and Asia. And especially the Jesuits were an important vehicle of communication and transmission of various kinds of knowledge from Europe to other countries. I've reproduced these two maps. They're both Middle Ages, medieval, and early modern period. But the maps, if you look at them closely, the map on the left is a map of the major trading routes in the late Middle Ages. And as you see, there was extensive communication and travel among cities across the whole continent of Europe. We could also look at maps showing travel and commerce to Asia and to the Americas. But just thinking about Europe, there was extensive travel and communication, which involved goods, but it also involved ideas and books and pamphlets and letters. On the right, you see a map of the distribution of the major universities across the face of Europe. Again, what it establishes is, in the late Middle Ages, extensive learning embodied in universities in many cities across the face of Europe. And in fact, if you look at, there's a list in Wikipedia of the universities which existed at the end of the Middle Ages and in the Renaissance, and it's a very extensive list of universities across the face of Europe. I didn't reproduce that, but you can find it easily. So Hobbes meets Galileo. The New Yorker used to run a kind of a regular feature of unusual meetings. I find this a pretty unusual meeting, but quoting from an article which I can provide a reference for, during a stay in Geneva, Hobbes apparently came across a copy of Euclid's Elements, quote, in a gentleman's library, which happened to be open to the Pythagorean theorem. As Aubrey tells the story, Hobbes at first found the theorem incredible, i.e., he had never been exposed to Euclid. But after tracing the result back through intermediate results to arrive at first principles, he was convinced of the theorem's truth and of the power of the geometric method. This chance encounter with Euclid ensured that, quote, from that moment on, Hobbes was in love with geometry. This is such an interesting encounter, not with an individual, but with an idea. And what we kind of can take from this is the deductive method, which Hobbes then tried to embody in his philosophy of the state, his theory of the state. And in fact, here in Hobbes's own writing is a statement of how much impact this had. I won't try to read this because it's in what we would call rather poor spelling, But basically, he is writing to his patron of his enthusiasm to buy a copy of Galileo's book, and how excited he was to be able to get a copy of Galileo's book for himself and also for his patron. In 1636, another tour in Europe brought Hobbes to Italy again, and there he did meet Galileo. Galileo writes of this visit, "I have had many visits by persons from beyond the Alps in the last few days, among them an English lord who tells me that my unfortunate dialogue is to be translated into that language, English, something that can only be considered to my advantage." And Jessup writes, "The English lord is almost certainly Devonshire. The projected English translation of the dialogue is the one which Dr. Joseph Webb had mentioned in Hobbes's letter to Newcastle. It is therefore likely that Hobbes met Galileo in December of 1635, although Hobbes was not known otherwise to be in Florence until April of 1636. But without doubt, Hobbes and Galileo had meetings and did have conversation. Descartes also had read a great deal of Galileo's writings. Descartes was younger, born 32 years after Galileo, but they lived at the same time. And Descartes' view of Galileo was less positive. He was less of a fan of Galileo than was Hobbes. And he faulted in particular the rigor and logical unity of Galileo's arguments about motion and objects. This is a very interesting passage from Descartes, which I won't read to you, but it basically says that he finds him to be greatly deficient in that he digresses continually and that he does not stop to explain fully any subject. These are gross intellectual faults, according to Descartes, who was a rigorously logical philosophical thinker. Let me turn quickly to Baruch Spinoza, who was the foremost Jewish philosopher of the early modern period. He lived 1632 to 1677. Notice what a short time that is. And he had something else in common with Galileo. But let me read a short passage that just kind of situates Spinoza. My purpose in this paper, this is from Udovsky, my purpose in this paper is to explore what happens when a scientific methodology rooted in mathematical geometry is applied to biblical hermeneutics. Galileo and Spinoza are both thinkers who, in their adoption of the methods of philosophy and science, challenged the limits of their social, intellectual, and theological margins. Both thinkers were regarded by their peers as threats to the institutional life of their respective communities. Both espoused doctrines that were regarded as heretical by their governing bodies. What I shall try to demonstrate is that Galileo and Spinoza share a methodological program of natural science, which, rooted in a mathematical view of nature, is then applied to Scripture. It is this methodological preoccupation that dooms them both and untimely subjects them to the charge of heresy. So this is the surprise. Both Galileo and Spinoza, one Catholic, one Jewish, they were both charged with heresy because of their interpretations of the Bible or the Torah. They both address the same astronomical claim made in the Bible and the Torah. The Torah is simply the first, well, the Old Testament is the biblical Torah in the Jewish tradition. And the passage in question is Joshua 10, 12 through 13, in which God is said to make the sun stand still. And as we've seen from reading the relevant letter from Galileo, but it's also true of Spinoza, both of them offer scientific and mathematical reasons for believing this is impossible, even for God. So quoting again from the same article, both Galileo and Spinoza, concerned as they were to free philosophy and science from the shackles of theology, held controversial views that threatened the ideological fabric of their respective religious institutions. It is important to note that although Spinoza's views were not actually published before his excommunication, Galileo was not shy about publicizing his position, as apparent in his letter to the Grand Duchess Christina. But in both cases, their perceived views were regarded with suspicion. For Galileo, it is the Church in Rome which objects to the ideology reflected in the letter, whereas in the case of Spinoza, it is the rabbinical court in Amsterdam which objects to the perceived, quote, objectionable views and heresies reflected in Spinoza's conduct and thought. Quoting again, Spinoza was accused of heresy in 1656, refused to recant, was excommunicated from the Jewish community, changed his name from Baruch to Benedict, and lived the remainder of his short life on the margins of the Jewish world. And now consider, actually I will read to you the finding of guilt against Spinoza. This is the governing body of called Parnassim and Gabai, which is quoted by Rudowsky. Having long known of the evil opinions and acts of Baruch de Spinoza, they have endeavored by various means and promises to turn him from his evil ways, but having failed to make him mend his wicked ways, and on the contrary, daily receiving more and more serious information about the abomination and abominable heresies which he practiced and taught, and about his monstrous deeds, and having for this numerous trustworthy witnesses who have deposed and borne witness to this effect in the presence of the said Espinoza, they become convinced of the truth of this matter, and they have decided, with their consent, that the said Espinoza shall be excommunicated and expelled from the people of Israel. So that is the finding of guilt by Spinoza for his ideas expressed only in private communications. And now the guilty verdict of Galileo. This is what was found in the finding of heresy against Galileo, and actually it's a moderate finding of heresy. We say, pronounce, sentence, and declare to you, the said Galileo, by reason of the matters adduced in trial, and by you confessed as above, have rendered yourself in the judgment of this holy office vehemently suspected of heresy, namely of having believed and held the doctrine, which is false and contrary to the sacred and divine scriptures, that the sun is the center of the world and does not move from east to west, and that the earth moves and is not the center of the world, and that an opinion may be held and defended as probable after it has been declared and defined to be contrary to the Holy Scripture. But the Rudowsky article, which I'm relying on here, his view of the real crime of both of these philosopher-scientists is the same. It is their insistence that mathematics and scientific reasoning allow them to correct the writings of the scriptures. It is a question of doctrinal authority. Who has the authority to correct the scriptures? And both the Jewish hierarchy and the Catholic hierarchy believe that is for the religious authorities, not for the scientific or mathematical or philosophical authorities. So let's talk a little bit about the Catholic Church. I've kind of suggested this conflict of Galileo's is actually a kind of a minor part of the Galileo story. But the doctrines and texts of Christianity were formalized in the centuries following the death of Jesus. I think that's the first time we've mentioned Jesus in this course. The Catholic Church became a hierarchical system of authority for believers. The texts of the church were stipulated as truths under the sacred authority of the Catholic Church, and deviations from the texts of the church were declared to be heresy. The sacred texts often made claims about nature, the universe, and the history of the world that Galileo and other philosophers believed were properly the subject of scientific investigation, physics, astronomy, and geology. So Galileo's scientific research brought him into conflict with the Catholic Church and the Inquisition, and it was kind of an elliptical conflict. It was not an unavoidable conflict. And through a very legalistic process, Galileo was charged and investigated with the crime of heresy. He was found guilty of an intermediate level of heresy and was punished, though the punishment, unlike Bruno, was very mild. It was house arrest. I would put it to you that the Galileo affair can be understood as a conflict between reason and science and dogma and religious authority, but it is a relatively small part of Galileo's significance. Now, why would we imagine that there is a conflict between science and religion? Science, we might think, has to do with facts about the world, and religion has to do with the possibility of divine creation, miracles, non-traditional causes. Traditions of religion are sometimes enfolded into coercive political and social arrangements with experts, priests, rabbis, imams, sages, who are thought to have direct access to religious truths, and there is some possibility of dogmatic belief being encouraged or required. And of course, that's what we saw in the trial both of Spinoza and also of Galileo. And when the nature of the earth, the planets, and the sun comes into biblical texts, then there is the possibility of conflict between religious conviction and scientific discovery. So for Galileo to attempt to dispute biblical statements about the history of the earth, the planets, and the sun, this was taken to dispute the authority of the Bible and the authority of the church. It was heresy. And yet, in the development of science and rational philosophy, it was a relatively small barrier.